puts zoom into a single point on a curve. No matter how close we get, we never actually arrive. The structure keeps unfolding. Some mathematical objects are not things you reach, they're things you approach. Some points collapse, some points don't. There's a famous unsolved problem in mathematics called the Birch-Swinnerton-Dyer Conjecture. Most attempts to solve it fail for the same simple reason. They try to recover information after it's already been destroyed. On the left, everything collapses into a single point. That collapse throws information away. But many approaches still try to pull structure back out by zooming in, differentiating, or pushing harder. Visually, that looks like arrows exploding from dots. They move, they grow, but they never settle. That's not a calculation error. It's asking the impossible. So instead of trying to reverse the collapse, we change the question. The operational view never tries to undo the collapse, but instead it asks what survives it. On one side, the collapse tells us how many independent problems remain unresolved. Not how big they are, just how many. On the other side, we look at systems built in layers. Most patterns disappear as the layers deepen, but some threads just keep going, unchanged, stable, and persistent. Those surviving threads are the real structure. The conjecture then says something surprisingly simple. The number of unresolved problems equals the number of threads that survive every layer. It's not about rebuilding what collapsed, it's about recognizing what never disappeared.